Good evening, everyone. Once again, tonight, is Orbit Fab going to the dark side? This may actually become a trend. Rocket Lab seeks to acquire Mynaric. A report this week claims that current space law does not actually protect historical sites, mining operations, or even bases on the moon. So what are we doing it for? What the new German Phoenix launcher may mean for the industry as a whole. A homegrown Australian launch startup is ready to fly. And what is a rotating detonation rocket engine anyway? All this, plus our guest Lee Steinke, coming up. From the news desk, Center for Space Commerce and Finance, my name is Thomas Andrew Olson, and this is the Emily Topic. Good evening, everybody, and welcome back. As you know, this show is sponsored and hosted by the Center for Space Commerce and Finance. What is the center? As you know, I'm going to tell you anyway. We champion and strengthen emerging space startups, space scalable small and medium businesses, and space adjacent enterprises worldwide through advisory, access, and advocacy across the funding spectrum. Our programs fortify business plans and investor readiness for founding teams at varying levels of development. A lot of our work, especially this podcast, is supported by our listeners and fans like you. If you go to the QR code at the upper left of the screen, it will take you to our donation portal. Keep helping us out. A little in the tip jar each month makes a big difference. Thank you in advance. Joining me now is one of my podcast producers and entrepreneur, one of my oldest space friends, Michael Lane from Liftport. Michael, get in here. Great seeing you.
Hey, how are you?
I am okay. I'm none the worse for wear. My back's better. Things are good. Things are good.
Good. It's another rainy day in Seattle. That's how we roll. It was sunny just a little while ago, but it's
Yep. Well, it's another sunny day again in Florida. So
what a surprise.
Here we are.
I had a coyote right here. I had a coyote today. I've lived here 2.5 years. I've never seen a coyote. And I'm not like deep in the woods, but
the last time we were here, I saw your cat wandering in the back. I hope the coyote isn't hunting him down, because I was living in Pennsylvania. We had a whole feral colony, and they were getting eaten one by a coyote.
Wow. Yeah. No, they're not my cats.
That's not good at all.
I'm watching them. Yeah, I'm watching them for sure.
Good.
Yeah.
Good. Okay. What is up with Orbit Fab? This is interesting because they've been. I'm not trying to be snarky with this. They're going to the dark side, but it raises a question that actually you brought up in a private email thread either yesterday or the day before, and that's why I'm bringing it up. Because Orbit Fab, they've had some great funding successes. They've had some great development successes. I don't know if they're having an issue with customers at this point, or further business development in the niche that they're using. But they all of a sudden made a big announcement that they're strengthening their advisory board with Space Command veterans, and they want to enhance the national security focus, which means they're going after more defense contract type work.
Right.
And is this becoming a trend? Because I saw a couple other companies starting to do that too. You've considered it yourself for Liftport.
Absolutely, for
and
sure.
I think one of the reasons was in that thread by one of your buddies. I don't know if you want to name those people, but I remember that. I don't know why I was even in on that conversation, honestly. But now I have to bring it back and talk to you about it, because that guy was saying something about how given the current disruptions that are going on in the global economy and everything else, the investment climate has changed significantly in certain areas.
Yeah.
Even though the satellite industry continues to have modest revenue growth, they seem to be pretty steady. Everything else, the new money coming in at the angel and VC level, might be shifting a little bit.
The Trump administration today announced again, reinforced, they've made this claim several times, but they did again today, about $1 trillion DoD budget. And there's talk about this golden dome, um,
Ugh.
stretching out into forever,
Infinity. Yeah.
forever, right? A new gigantic system that's a cost center, and that there's going to be a lot of folks in space that are going to benefit from that. So that's just one example.
Yeah.
But the coffers for the Department of Defense are so deep, and they are so interested in exploring this new space sector to understand how that can affect the warfighter with boots on the ground.
Yeah.
So this is a trend. It's been happening for probably 2 years now. I do find it a little bit interesting because it wasn't that long ago that there was an article that said that senior leadership at Space Force were unsure of the usefulness of a gas station on orbit. I think they're going to find that they're wrong about that. I definitely think there's value of a gas station on orbit, but yeah, this whole trend, the whole industry is moving this direction, and there's long been this ideal of dual use technology, something we can use on the ground versus use in space. Well, now it's dual use means, is there a defense application and also a consumer application, business application? So yeah, we're going to see this for a long time. This is the new reality.
Okay. All right. Then I guess we will look more for it. I'm just looking for something here. I wanted to go to, where is it? Oh, yeah. The next up, Rocket Lab is, after all the things that it's been doing, it seems like we talk about them every week now. And
we do, yeah.
And now all of a sudden, they're planning an acquisition of a German optical communications supplier. And I thought, what is this about? And it turns out they want to do this because it completes a restructuring process under German law, but there's also regulatory processes you got to do. Mm-hmm. But it would give Rocket Lab its first presence in Europe, and he wants to win orders from. They want to win orders from European government agencies. So if you're outside Europe, that's far more difficult, obviously. So they want to offer Mynaric terminals as a merchant supplier to other companies. And that's going to be part, and that technology is an essential part of their vertical integration efforts. And so they're looking for a reliable, scaled supply of components for their own aspirations, as they say.
Right.
And those constellations could be for other customers as well.
I find Rocket Lab to be kind of a fascinating company. And you're right. We talk about them. This is probably the 5th or 6th week in a row that we've talked about them because they're making news. They're doing big things regularly. A couple of weeks ago, it was their flat satellite, what I call IKEA Sat, what they called Flatellite, I think, I think my brand name is way better than theirs. But yeah, they're taking a page from the SpaceX and the Amazon Kuiper playbook, and they're going to build their own constellation. In the chat, somebody was, I think Doug was asking, Dr. Plata was asking if LEO is
GEO is being undermined by yeah. Well, if you read the reports from the owners of the GEO and I just read this today in some other place. I don't have it linked up, but I just read that today. The people running the current satellite businesses they haven't lost a dime yet.
Right.
They haven't been cut out of anything so far, and people don't realize. And this is actually, I have to do a shameless plug too, since you did. It's the reason Avialto is in business.
Yeah.
There are a lot of places around the world where about 2.3 billion people actually live who can't afford Starlink.
Right.
And can't afford that extra, hundreds of dollars for a special receiver to receive Starlink. Some people might have the little standard antenna they've been using to to file their reports and manage their credit cards, stuff for a long time. And then you get out in the country, they don't even have that. But those those little receivers are not very expensive. They're like $100 or less, and you can share one. And so out there, so in those 6,000 Indonesian islands, for example, they're going to be using a high altitude platform like ours, and they're going to be paying a fraction of the price that Starlink will charge, and we can still make money.
Yeah.
And shameless plug. Okay.
There is a near endless demand for the services that are both LEO and GEO, and certainly with more than 11,000 assets flying, mostly all in LEO, there's a lot less activity in GEO. There has been for years. There's been less and less and less GEO activity, but I don't think it's hurting anybody.
The terrestrial guys and the GEO guys are still wait and see, saying, they got a lot of stuff up there, but they're not really cracking the surface as far as making some serious revenue yet. And so, is it a big experiment that's going to not work out very well, or will it actually be disruptive and take over the world? Well, it's not disrupting anything yet, and so they're all saying, well, we'll wait and see. But right now, we're doing fine.
Yeah.
So. Interesting. Now I got something interesting. I want to pop this up because we also talk about space law on this show. We talk about how we figure out mineral rights, how we do development, and this interesting individual. And let me say her name is Michelle L.D. Hanlon, a professor of air and space law at the University of Mississippi, published this thing on Space Daily today, and she actually is also a space lawyer. She's a co-founder of For All Moonkind, which is a nonprofit dedicated to protecting the human heritage in outer space. And so she knows that the moon could be the proving ground for our evolution into a species that lives and thrives on more than one planet. That's great. But from a legal perspective, it's a unique domain without terrestrial equivalent. It's not the high seas, the common heritage of mankind. It's not an area like Antarctica where commercial mining is prohibited. The Outer Space Treaty established that exploration and use of space are the province of all humankind, which means no nation state may claim territory. But it didn't say anything, and this is what we've been living on, is while a country can't claim territory, we can still extract, people from that country can extract the resources of certain extraterrestrial bodies, and they can make money off of it. Of course, the question is, if your grandchildren move to Mars, will they never actually own a home?
Right.
So how do you protect your investment in a lunar mine if it must be freely accessible by all under these treaties? And what happens when two rovers race to a particular area on the lunar surface known to host something, very valuable like helium-3 or even water ice? Is it winner take all, or is there going to be a fight out there by robots?
I'm betting on a robot fight myself.
Yeah. Well, then they could make money. They could charge pay-per-view to watch this.
So I have known Dr. Hanlon for at least 7 years. I have sent 2 interns her direction. So one is graduate and one, that one's not an intern. That's not fair. I've sent 1 intern and 1 kind of acquaintance to her classes down in Mississippi. It's weird because, it's kind of weird. There's kind of 3 centers of knowledge in the space community for law. There's George Washington University in Washington, D.C. There's McGill in Montreal, Canada. And then there's Jesus, what's it called? The one in the Netherlands that I'm suddenly drawing a blank on. There's 3, right? And so then there's this Ole Miss down in Mississippi that for the last 10, 12, 15 years, 20 years, they had a gal named Dr. Gabrinowitz who was really looking at satellite law, just satellites. It wasn't messing with anything else, just how do you manage frequency and spectrum regulation and management. And they carved this little niche out. And then Dr. Hanlon comes in, and now I'm pretty sure she's the chair. Gabrenos has retired, and Hanlon's really interested in the moon. And so they are carving out a specialty knowledge environment for mineral rights and the moon. And that's how For All Moonkind came online. So I have a lot of respect for Hanlon. I didn't read this article until you sent it to me, so I don't have a lot of background on what this article says, but that professor impresses the hell out of me. So I will read this actually after the show. That's all.
Well, yeah, I had to skim it myself, but the idea, I just was tickled by the idea that everything we've been trying to do for 60 years in space law may amount to a hill of beans that no one can claim as their own.
I think the Artemis Accords are, and I know that Hanlon supports the Artemis Accords. I think they, with 50 nations supporting them, that becomes, even if it's not a treaty that everybody agrees to, it's a common law practice that will eventually codify into action.
Yeah, maybe sooner or later. Hope so. Hope it's not any more than that. Because when I first looked at that, I read up after I read this article a little bit. I went back and started looking up the Artemis Accords because two more countries just signed on. This week.
I didn't know that.
Including Norway. And so I wanted to find out whether this is another, like another nuclear test ban treaty. Like the George Carlin joke. Chad, Sierra Leone, Monaco, Upper Volta, and Iceland, signed the nuclear test ban treaty. Like that. We're doing the same with Artemis now. We're just gonna. It's just a backdoor way to try to get us to that, false promise of the Moon Treaty. After all, and it doesn't seem to be. They're basically saying, no, you can do business. We just share our data, and we stay out of each other's way, and we tell everyone what we're doing. We're totally transparent about our activity. So that's really all it boils down to in anything that matters.
I think it's really going to look a lot like farm fishing up in Alaska, where you have a piece of real estate, you mark it out, put markers on, say this is the place that we're working. You don't claim it, you don't get to own it or stake a claim, but you do have economic incentives and you do have non-interference rights. And those are protected by the law of the sea. I think it's going to be a lot like that. A lot.
That has worked.
Yes.
And so that's let's see, when we do stuff out there, we should at least do what works.
Yeah. Right.
Because we're humans and we carry our baggage with us wherever we go.
Although
there's a lot of stuff we could bring with us that just never worked at all, but we're going to do it anyway.
A robot fight. Now I'm kind of thinking I want to see that. So. Maybe that's what we get is we have gladiator roles on the moon, and whomever can build the baddest ass robot gets to claim that location. I'm kind of okay with that.
Rock'em sock'em robots. Here we go.
Exactly.
It's back. We're back. Doug asked an interesting thing. He said, if the settlers on Mars declare their political independence and choose to not sign the Outer Space Treaty, or actually in this case withdraw from it, since they were part of it when they first settled Mars. Will they be bound by it if they leave? And if not, could they set their own property rights? I would say the same thing would be true on Mars as is true in the Americas, as is true everywhere else humans have settled throughout history. You can only claim what you can defend, effectively. Now, the vast distances right now between planets, makes defending those claims a little easier. Moon is harsh mistress scenario, not so much on Mars, but in the depths of the deep state, there's a guy there that looks like Fox Mulder that has that dog-eared copy of Moon is the Harsh Mistress that he reads once a year just to get himself all excited about. These are things we need to do, or they're going to throw rocks at us.
I got that on my shelf, man. That's not. That's one of my favorite books.
I know it is. That's a very libertarian novel, by the way.
Yeah,
that's how we knew Heinlein moved from his fascist period into his libertarian period. I think that was the novel that started him, intellectually down that road. But now we're going way
Way off track,
like we always do. And
right,
so,
right. What do you want to talk about this?
Yeah, it's something I was trying to look at this and try to figure out, what, because it's something, why does this matter to the entire space industry?
Right.
And I think it has to do with part of their new materials that they're using for heat shields, one thing, and thermal protection. That's a big deal. And there's something they call IADs. I'm trying to figure out what IADs mean. NASA tested their own 3 years ago. It's an inflatable decelerator. Is that what it is? Right. Okay. Yeah. And sometimes they use aerogels and sometimes they use other things. But a success in this, now there's a lack of capsule recovery for Phoenix 1, but it was still viewed as a success. And they got all the mission and payload data. Now, it's unclear what state the heat shield was in impact with the ocean, but there's already plans for a Phoenix 2. They're going to reiterate, they're going to update. So it's a SpaceX model: fly stuff fast, break some stuff, learn things, and keep doing it. And so really, it's the heat shield and thermal protection thing that might change the game. And they'll be, if they succeed, they'll be at the forefront of it.
And just Monday, we were talking about a different plan for heat shields, right? Absolutely. This is becoming a really common theme in the industry.
Yep.
And when we bring on our guest in a minute, there's this idea of the on-orbit assembly and manufacture idea, in-space assembly and manufacture, ISAM, that really didn't come to fruition the way folks had hoped. And the problem was this reentry piece. So you're seeing the same thing. Varda, now they landed. This is their second mission. So that's really great out in the outback of Australia.
Yeah.
But we, in the same way we keep talking about Rocket Lab lately, we're also really talking a lot about reentry. So those are
we're just kind of becoming the oracles of Delphi here on this show. Yeah, I think we were bringing this stuff up. We were here first.
We were here first. Topics. We've been doing this for 25 years.
Come on. Keep watching us. We'll keep up.
We've been the oracles.
I want to do one more thing, then we got to get to our guest. We're already running a little behind. Right. Which is you sent me this, so I have to bring this up. It was the rotating detonation rocket engine. What the hell is that? And why is this important?
Yeah. This one, I think this was a big deal. I think this is the biggest news of the week. It's a company that I've literally never heard of until it blew up on my LinkedIn account yesterday. Venus Aerospace. You ever heard of it?
No.
Do you know who they are? No,
I don't know.
Nope. They were brand new to me. And I can't say one sentence about their company. What I can say is rotating technology for a rocket engine is very cool. It's very hard. It gives you a lot of extra energy. It's highly efficient. And if other rocket companies can mimic that, it's an industry changer.
This is insane. I'm looking at this right now. This is absolutely insane. Right. And so
it is
usually a traditional rocket engine. You have a highly pressurized propellant and an oxidizer. They're put into a combustion chamber and they burn and produce a plume.
Right.
A rotating detonation engine, you have a wave of detonation that travels around a circular channel and is sustained by the injection of fuel and oxidizer and then produces a shock wave that travels outward at supersonic speed.
Mm-hmm.
Whoa.
This was once explained to me. Remember the old-fashioned Gatling guns? You'd have and you'd fire a bullet. It kind of looks like that. It kind of works like that. Now, I'm not enough of an expert on this tech. I'm not trying to vouch for it, but I heard about this years and years ago. Yeah, it's a Gatling rocket engine. Exactly, Sawyer. That's kind of what it looks like. That's kind of how it operates.
That they say their goal is to do hypersonic flight.
And
hypersonic
right?
fly for commercial and defense
They,
applications. So, yeah, I get it.
yeah, I'm a big believer in point-to-point suborbital. I think,
Yeah,
this might be one of the techs that we use for the technologies for point-to-point suborbital. So
I would
yeah,
love to see it.
I do. I think it's the biggest news of the week. I'm going to bring up one more thing just briefly because space and money. The industry is growing.
Yep.
We're not making the money that we were.
Yeah. First,
This
that's more
report's pretty
traditional.
interesting.
That's
I
more
do
traditional
actually.
satellite. That's more traditional satellite. So,
Yep.
it's not as much as like all the entrepreneurial stuff that we talk about every day here. That's still an issue, and we'll probably we're gonna have to do a show. It won't be next week, but maybe after we can do a show and really talk about what the trends are right now in the actual investment and where they're coming from, and get one of our buddies at Starbridge or Space Fund to come on and talk about that. I think it's important.
And you know, do some analysis. Yeah.
Yep.
I love when they talk about the space hockey stick, right? Just we're launching a bunch of stuff. It's making money. It takes a while. There's a lot of capital expenses to get this stuff going, but we're seeing this industry transform before our eyes. And I like seeing that. And the more stuff there is out there, the better all of us
That's
are.
true. That's true. And so if you're ready, we're going to go to our guest. It's a little bit late.
Yeah.
I apologize about that because we go mad. We go crazy on this stuff. And so, but our guest has been very patient. Her name is Lee Steinke. She is COO of Cislunar Industries. She's been advisor of the aerospace, defense, and energy sector. She's had quite the career and a very fast rise. And now she's part of this really, really interesting and great company. We're going to hear all about it. Lee, welcome to the program.
Thank you so much.
It's so good to see you.
Great to be back on camera with you guys after a couple of years.
Yeah, we did. Yeah, you and I and Michael all were doing those business plan events virtually for Foundation for the Future, and those were very interesting. And then and so, but then, like I said before the show, it says then you went kind of skyrocketing like this, and I came here. So,
well, so much of what I knew in my first year, I learned from you guys. So,
well, that's so generous of you to say. Anyway, let's explore this with our viewers here, because you've had quite a path to get where you are. You've been in the oil and gas industry. You've consulted in defense and aerospace, and now you're COO of this really incredible company, and which I want to find out all about. But tell us how you started. How'd you get here? What was your path?
Yeah, so in 2020, nothing strange was happening in 2020. I thought about whether to hang out and wait for oil and gas to come back or try something new. And I didn't really have my eyes on aerospace at all, but I started poking around different industries. And I had followed ESA and NASA several years before because I liked the images of 67P. That was like just looked like a real place. It really captured my imagination. And so I'd been following NASA on Twitter, and when I looked at the space industry, I was like, wait a minute, this is a big deal in Colorado, where I didn't want to move away from. It was facing disruption. You guys are talking just a minute ago about the growth in the industry and the trajectory, and now huge budgets coming out of DoD. I saw that there were new technologies that were driving change. There were new commercial activities that were driving change. New government behaviors driving change, and cost reductions achieved that would also result in great change. And so it just looked like an exciting place that felt to me a lot like the shale revolution, where, again, new technologies were combining to create commercial momentum. And it just felt so similar to that. And I was really, really excited about it. And so I started volunteering for Space Foundation for nothing. And then I got in doing this Conversations for the Future program. I did that for about 8 months with Michael. And then we, through that program, I think the first 5 jobs that I got in aerospace, individual jobs, and then including the COO job, were from people that I interviewed either on Conversations for the Future or through Space Foundation. It was shocking, really, because you get to know somebody quite well when you're interviewing them. You really have to pay attention to all what they're saying, and then you read a little bit up front about what they're doing, and it's a great way to get to know people. And so that was a very fruitful way for me to dive into this industry.
It really was. Those were good days. Despite the world being on fire, the Foundation for the Future had some very catalytic moments. Like, they were able to do interesting things, maybe not what they had hoped for originally, what they planned for, but they were catalysts for other things, which I think is pretty terrific. Yeah.
I noticed somebody said there's an echo. Is that coming from me or?
No, you're fine. You sound fine.
All right.
Yeah. The hazards of doing this live. We checked our mics before, and everything was fine. So, magic. It's Michael's fault? Are you kidding me?
there's a public chat, and then there's a behind the scenes chat, and these guys are
right. All right. Well, I've turned my mic down a little bit as well. All right. So that's a little bit of your origin story. What have you been doing? Like, what are you doing day to day? What's your role at SysLunar? Talk about SysLunar for a second.
I want to know what this is and what it does, and what your business model is, and who you're selling to, and what is this all about. Because you're saying you're doing switches for energy delivery and other electronic stuff. Obviously, you found this interesting niche, and I want to know all about it.
Excellent. Yes. So SysLunar Industries, we were founded with this big vision of processing metal materials on orbit and on the moon, so we could take, for example, an old rocket body and recycle it into useful products for space construction, like rods, tubes, sheet metal, and even wire. We've made a wire maker for NASA. And then that started to evolve. We got a DARPA contract to process lunar material. So post deoxygenation, we could take lunar material, process that, and then we studied how we would interface with other companies that were on the lunar economy, and did this whole DARPA Luna 10 program with 14 companies. And we just met with each other over the weeks. They would pair us, DARPA would pair us up with one of the partner companies, and we would talk about, well, if I were doing business with you on the lunar surface, what would be the specifications of our interaction, right? So if you were going to give me slag from your deoxygenation process, what would I do with that? And what form would it take? Would you sell it to me, or would you pay me to process it? Right? So there are all these questions. And then when we deliver it to our customer on the moon, like Northrop Grumman, the rails that they published articles about, would you pay us to make the rails, or would we sell you rail material? Like what, right? And so all these conversations, and that's going to result in a book that comes out. And so now we're doing both natural and man-made products, processing them and turning them into useful products. And then we got a Space Force contract to turn debris into Delta V. So debris to Delta V, meaning we could take an old piece of satellite or rocket body and turn it into solid metal propellant. And that was a fantastic program. we learned a ton about the efficiencies and the value of in situ resource development and utilization, the cost difference between launching hydrazine from Earth or other fuels from Earth, buying them, or they're way more expensive than aluminum to begin with. You have to launch them versus having them already in space. And then in some cases, they're less mass efficient. So that then when you look on per delta unit of delta V, the hundreds of times difference between the cost of launching refueling from Earth versus providing propellant that's recycled right at the point of need. So we learned fascinating things, like recycling only 2 GEO satellites could provide all of the station keeping propulsion needs or propellant needs of the entire GEO fleet.
Yep.
And then space station waste metal we looked at, because there's all this challenge of, we have to our partners have to capture and do all these different technologies to make the whole value chain work. And so we narrowed it down. What could we do just on a space station? And it turns out space stations have all kinds of waste metal.
Tons.
We got estimates of waste metal, and we calculated that most space stations could probably do all of their space station keeping propulsion with they would cover half of it with their own waste.
That's bonkers.
Fantastic stories there. But when we did that project, it put us in propulsion labs where we were testing how the metal propellant was performing and using simulated debris and running in running this thruster in a vacuum chamber. And when the propulsion experts saw our power converter that we had built, they recognized its potential as across the industry, all different kinds of applications, especially power processing units for electric propulsion. And so they told us about it, and we learned about it, and we just jumped right in and did what they said. And we had a Today market right at the same time that NASA was kind of not asking for solicitations for metal processing. 2 or 3 solicitations in a row, didn't have anything. And so it was great timing to balance. I know.
Hang on a second, because I want to stress that this is not a theoretical idea. This is something you've actually done in the lab and showcased it. So I'm not going to pull up this video because it's a long video, but this video here in the corner and what you're seeing on the screen here, that is molten metal that I watched it on video. I watched it melt before my eyes. So this is not a theoretical technology. This is a known technology that they've demonstrated at the lab. And then the power conversion piece, same story, right? So I just want to we have guests on the show that talk about the someday technologies they're working on. I want people to understand that this is a current, we're doing it, we've done it, we're going to do it some more technology, right?
Yeah,
that's important to bring up. Yeah.
I want to jump on those videos. So we've tested on a parabolic flight. We've tested the Foundry on 3 parabolic flights now.
I've seen you flying through parabolic flight. It's a good time. Yeah.
But the cool thing is we just published a peer-reviewed paper, our first peer-reviewed paper on the STEER system, which was designed, when you have molten metal and you can't pour it, because terrestrially you would pour it. Mm-hmm. We were like, how are we going to handle that? And we have piston systems and encased programs, but also this STEER technology uses electromagnetics to manipulate and levitate. And that has all kinds of potential applications, both in space, on orbit, and on the lunar surface where everything's abrasive. If we could do contactless conveyance or processing of any kind, it will save your machinery and all that kind of stuff. So basically Star Trek tractor beams, or if you're a Star Wars person, the Force, you're basically turning those into a reality. We can literally write your name in the air using our technology. So
Okay.
It's that precise. It wasn't that precise last time I talked to you.
no, now we can draw a cube, all the different directions of a cube with a little aluminum ball. Yeah, it's pretty cool.
I've got a couple of technical questions from someone in the audience. And he was asked, I don't know if you can know anything about these. Sorry. He said, would you be using induction foundries in near zero G or other styles to heat and smelt the metal?
That is exactly what we do. It's an induction furnace. So we built a DC to AC converter because induction furnace uses AC power. It can process at 1.5 kilowatts. At 1 kilowatt, it can process about 1.5 kilograms of metal an hour.
Okay. And would y'all use ceramic syringes to withdraw the melted material from the molten core?
Yeah, so we have a variety of mechanisms for moving the molten metal and a variety of end effectors to produce the final products. So there's sort of 2 stages there. And the syringe idea is similar. One of the tests on the parabolic flight was a piston system, so similar to a syringe behavior. So you're absolutely right. And we use ceramics. We use a certain type of like a steel wool, but it's a ceramic wool for sealant and for insulation. And then the syringe, the cast that we use is either silicon carbide or we've experimented with different materials, and that you're on the right track.
Nice, cool. Thanks, Sawyer.
Yeah.
So, all right. So you started out doing this force on metals, right? And then your research partners convinced you there was a current technology. So I want to talk about the promise, and I think a little bit of the bait and switch of on-orbit service and manufacturing. And hold on, don't go anywhere. I'm not sure what happened. Hi, welcome back. Welcome to the show, Lee.
Thank you.
I want to talk about that evolution to the current product line, keeping in mind we only have 20 minutes, so just kind of being aware of that. But talk for a moment about what I feel. I'm not putting your words in your mouth. What I feel is a little bit of bait and switch that we were going to push towards on-orbit service and manufacturing, assembly and manufacturing, but that's not really happening right now. So you've kind of spent some time around the halls in DC. You've spent some time talking to folks. I'm not trying to put you on the spot. I don't want to get into politics, but where do you think OSAM is going, and why aren't we doing it yet?
Yeah, I think, I'm not going to speak for anyone else. And instead I'll give my own opinion. And that's that I think there's only so much progress that can be made when we distribute the money across all of these technologies at once and the capabilities at once, okay. Right? And I think that the budgets that were allocated were not big enough to do all those things, and that we saw, fits and starts in the advancements of capability on all these different fronts. And that there's a sort of feels like there's a natural narrowing happening that's focused on the very next phase, including anything that China is doing, where it's about dynamic space operations, as well as servicing in the way that you need to achieve dynamic space operations. So that means, being able to be on orbit, but not be predictable about where you will be in 6 hours. So being able to move at any time you want, and have enough resource on board to do that, or be able to receive resource to move freely. And so that plus robot arms to do whatever and the dynamics of moving around. Dog fighting in space is a recent headline that China was able to demonstrate. And I think it's similar to what maybe astroscale's circling of another spacecraft, defunct spacecraft, isn't quite the same as dogfighting, but it's the same skill, right?
Yeah, right.
So I think there's just sort of a natural, let's focus on what's really next and get that handled. And once we do that, it opens up, just the possibilities open up. So that's my feeling.
I've long known that there was an argument that we lost at the Pentagon that was it's described as the blue water versus the brown water.
Yes, I learned that from
ethos.
You.
I know.
And General Quast when I interviewed him.
I know. But there has been this blue water versus brown water, and for the folks on screen, speaking in Navy terms, I'm a former U.S. Marine. All Marine activity is near shore activity. There's not anything we can do out in the deep Pacific, right? That we don't have a role out there. Landing craft, that's all near shore, littoral, brown water, and submarines. They pretty much don't have a lot to do near shore. They spend all of their time lurking on the bottoms. So blue water versus brown water. Aircraft carriers tend to be blue water, although they have some limited capabilities near shore. So that idea, that ethos translated to space. Near shore meaning Leo and Geo, blue water meaning the moon, Mars, asteroids, cislunar space. So that argument came and went. The Pentagon decided what they're going to do a long time ago. And the blue didn't win. That they just didn't. And so I felt like OSAM, on orbit service and manufacturing, fell into that blue water camp and got dropped as a to-do list item because there was just more stuff happening near shore that we had to deal with sooner. And it's not exactly the same because
it's
CASIS and ISS has been trying to do stuff for a while, but so anyway, all right, so you're thinking it's more of a budget and a priority problem than anything else.
If it were all my money, that's how I would perceive it. And it's it may not be a reflection of what's really happening, but when you have so many independent actors influencing what's going on, and then you see this convergence, that's what it feels like to me.
Okay. So what is next, right? So your customers, you showed them some of your technology around the induction system, and they're like, yeah, but look over here. This thing that you're doing over there that you're not paying attention to, pay attention to that. So tell me about that. I don't know that much about that piece.
Yeah. So basically, almost everything in space runs on electricity. Mm-hmm. And every watt of that electricity has to pass through a power converter of some kind to take power from the solar panels and convert it into the right power form and voltage to run all the different things that it needs to run, whether you're on a spacecraft or a base or a rover or whatever it may be. And so all forms of that, they're all different kinds of specialized forms of power converter, both terrestrially and in space. And so we designed a modular configurable electric power converter and patented that right away as soon as we figured out we were doing this. And then we've continued to patent different aspects of it. So then now we have sort of a core design, then adaptations from that mean when we go from thruster company to thruster company as customers, or we go from thruster company to a satellite bus manufacturer as a customer, those designs, we don't have to redo the design like they've been doing for decades, right? Instead, we can leverage that core design and then go into the different product lines of power processing units or PMADs, power management and distribution units, or PDUs, and then there's ultra high voltage power supplies, which are for, you were mentioning the DoD increases in budget and the Golden Dome. Some of what we've built has been for, I think we flew the second or third highest voltage ever produced in space when we powered Think Orbital's mission for their e-beam welder in space. So we can apply this same core design that we call EPIC to all those different product lines, and then it makes them adaptable. And we can cut non-recurring engineering costs, which results in faster delivery times, which is important to customers because as SDA ramps up, people are now waiting 2 years for a power processing unit, either from their own people building them or from the people who are already building them and selling them to their customers. So we're entering an over demand market, an undersupplied market. So even if our product weren't better, it would probably still sell. And then ours is half the size, half the weight, half the thermal output.
That's the Microsoft theory there.
Yeah.
Yeah. Okay. My God.
So, go ahead, Tom. You were going to say something?
No, I was going. Well, see, I was going to go off on a tangent, and we shouldn't. We should stay in this topic. I race all the time. I want to get into a little oil and gas stuff, but no, we can talk about space tech. We can talk about space tech
another time.
Another time. So,
well, because this is the show about money and space, let's talk about money. So, where are you at? What are you doing? How many people are on payroll? Where are you located? I know some of these answers, but our guests, our audience doesn't. Talk about contracts. Talk about what's happening next. Yeah, we got 9 minutes.
Okay, so we're in Loveland, Colorado. We've grown from our CTO's garage to Orbit Fab's hallway. On their first floor, they have a hallway for startups. We had an office there for a little while. We graduated to a small, dilapidated little space, and then we graduated again into a beautiful place in the Forge campus in Loveland, where we're co-located with a contract manufacturer who can, who's working with us on those programs. And so that's been a wonderful evolution over time in terms of the resources that we have for our location and activities. And then we have, we've won, I think we've had 20 to 25 government and commercial contracts over our history and since 2019.
Yeah, I was going to say, you've only been around since 19. Yeah. Okay.
And so, those have been from NASA, Space Force, DARPA, commercial customers, everything from a small startup like Think Orbital to working with a couple of primes. And so both with them as some subcontractors and then with them as customers. So that's a nice way to work with the primes, is sort of that balance. And so it's great. We have great university partnerships, both in Colorado and beyond. And we're doing everything from supporting, huge up to, X-ray beams up to hundreds of thousands of volts, to nuclear electric propulsion to 100 kilowatts, right? And so huge range in all the activities that we're doing on the power side, all on that same core technology.
Wow, that's remarkable. I didn't have any idea you had that many contracts under your belt. Good for y'all.
Yeah. The smallest one's probably, the very smallest one was probably like between $5,000 and $10,000, and then the biggest one is $2.4 million, I think, so far.
Good for you. Yeah, who's the 2.4 for? What are you doing for that?
That one we signed with. There was a press release on our website with Atomos for their OTV.
Okay. All right.
Yeah.
Okay.
That's cool.
Quark OTV.
Nice. All right. What are we missing? What haven't we asked you about so far?
Well, there are a couple of questions in chat, but I kind of wanted to talk, because you guys like this kind of conversation, I wanted to talk about the evolution of the term cislunar.
Oh yeah, love it.
Our company is called Cislunar Industries.
Yep.
And what I've noticed over time, I learned from you, because I remember I made that little commercial. My daughter helped me edit the commercial for Conversations for the Future. And that commercial, we had you saying cislunar, from the surface of the earth to the surface of the moon, right? And the prefix cis means between here and there.
Yep. Yep.
Right. And so technically it means everything: Leo, Geo, Meo,
right,
XGO, lunar orbit, lunar surface. Some people even include Lagrange points. And so that's what I thought it meant. I was right. But the DoD, as they started to need these different locations, right? When you spend more time somewhere, you need more words for all the subdivisions of it, right? And then just sort of commandeered cislunar to mean only out there, right?
Yep.
And so now I did a LinkedIn poll on 4 different definitions, and I got a broad variety, and there were reputable space industry CEOs in 3 out of the 4 answers.
Okay.
And so it's just this really big difference. And I think that's going to happen a lot in our industry, because we're going to have so much more activity, so many more places that we're going on a regular basis. And you're going to find the words don't mean what they used to mean. And you have to keep learning and keep evolving with the dynamics of language. That's so much more interesting.
So where do you see yourselves now in a few years? I mean, you've gotten investment, you've gotten customers, you're building these great things, and you want to grow and you want to get bigger, and you want to do this and you want to have. Now, is your goal to be acquired? Is your goal, or is your goal just to grow and grow and grow and grow and stay there forever and take over the universe?
So I'm sorry, you wanted to talk about business models and growth. So
yeah,
right now we're in a unit sales mode.
Okay.
In a couple of years, we may, once our revenues are high enough, we may consider plans for people where they can buy by the kilowatt hour, right? So they do just pay for the power that they use, and they don't pay for the hardware up front. So it's a way for them to delay the cost, but then they could spend more if they have prolonged operations, right? So it's a nice balance when we're able to take that risk to try other business models. And then you get the data, and you can, the volume of data to be processed into models that you can learn from. So unit sales first, and then all kinds of possibilities after that. In terms of our exit, we haven't constrained what we're doing, but we could see a variety of exits, including a divergence, a partial exit from the power business as the ISAM business develops. So there are all kinds of different ways we could do that. And we certainly have customers already who could be in a position to buy us if the time when the situation were correct or were right.
All right. Well, I think you're certainly going to have no shortage of customers in the future for all this stuff. So I think the future is very bright for your company, and really thrilled to learn a lot more about it. But unfortunately, our time is coming to a close. I told you. What did I tell you? It goes so fast, doesn't it? We're going to have to do this again. After a while. And, are you coming to ISDC by chance?
I don't think I can come to that this year. I have a paper accepted to Sydney, and I'm trying to make that trip happen.
Right. It's too bad. I'm going to have the best business track ever. But they don't do live streaming. Those guys don't have the budget for that. So, you have to kind of show up. But Lee Steinke, it's been so nice to have you here. We must do this again.
It's delightful to see you both and spend the week together.
Thanks for being here. We appreciate it.
Bye.
Bye-bye.
Okay, next week. Oh my God, next week is going to be a very special week here at The Quantity, because we are dedicating not just one, but both shows next week, Monday the 19th and Thursday the 22nd, to someone I think of as the godfather of space podcasting, the man who started it all over 20 years ago, Dr. David Livingston, founder and host of The Space Show. Yes, the master interviewer will himself at long last be interviewed. by us.
It's going to be great.
From the news desk at the Center for Space Commerce and Finance, this has been Thomas Andrew Olson. Thank you for watching, and keep watching the skies.